హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు టెక్ ఎడ్ ఇన్ఫో ఛానల్. మరిన్ని వీడియోల కోసం సబ్స్క్రైబ్ చేయండి. Today I would like to tell about the project microcontroller based solar tracking system. In this abstract, solar energy is rapidly gaining notoriety as an important means of expanding renewable energy resources. As such, it is vital that those in engineering fields understand the technologies associated with this area. My project will include the design and construction of a microcontroller based solar tracking system. Solar tracking allows more energy to be produced because the solar array is able to remain aligned to the sun. This system builds upon the topics learned in this course. A working system will ultimately be demonstrated to validate the design. Problems and possible improvements will also be presented here. And now introduction. The renewable energy solutions are becoming increasing popular. Photovoltaic systems are but one example. Maximizing the power output from a solar system is desirable to increase the efficiency. In order to maximize the power output from the solar panels, one need to keep the panels aligned with the sun. As such, a means of tracking the sun is required. This is far more cost-effective solution than purchasing additional solar panels. It has been estimated that the yield from solar panels can be increased by 30 to 60% by utilizing a solar tracking system instead of a stationary array. This project develops an automatic tracking system which will keep the solar panels aligned with the sun in order to maximize the efficiency. Now, the components which are used in this system: microcontroller chip, microchip microcontroller PIC16F877, oscillator crystal 4 MHz, and voltage regulator 7805, photocell cadmium sulfide, step motor unipolar 5 volts, and capacitor 0.1 microfarads, capacitor 47 microfarads, resistor 10 kilo ohms, resistor 3.3 kilo ohms, diode 1N4003, transistor Darlington 2SD1276A, switch momentary push button normally open, motor sensor mounting accessories. These are the components which are used in this. Now, design of the software. Introduction to the Kale software. In this project, we are using the Kale software. This is a free software which solves many of the pain points for an embedded system developer. The software is an integrated development environment which integrated text editor to write program. A compile, it will convert your source code into hex file. Here is a simple guide to start working with the Kale microvision, which can be used for writing programs in C or C++ or assembly, compiling and assembly programs, debugging programs, creating hex and AXF and bin file, text program without real hardware. Now, the overview of the embedded system. Now, let us see the details of the various blocks of the hardware of an embedded system. The building blocks are central processing unit CPU, memory, RAM and ROM, including input devices, output devices, communication interfaces, application specific circuitry. In this, the block diagram is shown here, and the input devices is connected to the CPU. The CPU is interfacing with the RAM, ROM and application oriented specific circuitry and communication interfaces, and this get output, and the get output gives to the output devices. This is the overview of the embedded system. Now, the power supply. The power supply are designed to convert high voltage AC mains electricity to a suitable low voltage supply for an electronic circuits and other devices. A power supply can be broken down into a series of blocks, each of which performs a particular function. A DC power supply, which maintains the output voltage constant irrespective of the AC mains fluctuations or load variations, is known as regulated DC power supply. In this, the block diagram of the power supply is here. In this, we have a AC line, and the terminals are AC line, and this the AC line is given to the transformer. The transformer converts high voltage AC mains electricity to the suitable low voltage power supply, and this it gives to the rectifier, and rectifier converts AC to DC, and the and this output of the rectifier is given to the filter and filter out the any harmonics, and the filter output is given to the regulator. The regulator sends the output voltage constant, and the output of regulator is given to the load. This is about the power supply. And this now we are talking about the LDR. LDR is a light dependent resistor, or an photoresistor is a device whose resistivity is a function of the incident electromagnetic radiation. Hence, they are light sensitive devices. They are also called as photoconductors. Photoconductive cells are simply photocells. They are made up of semiconductors material having high resistance. There are many different symbols used to indicate the LDR. One of the most commonly used for the symbol is shown in the figure below. The arrow indicates the light falling on it, LDR. And working principle of the LDR. A light dependent resistor works on the principle of the photoconductivity. Photoconductivity is an optimal phenomena in which the material conductivity is increased when the light is absorbed by the material. When the sunlight falls, that is, when the photons fall on the device, the electrons in the valence band of the conduction semiconductor material or excited to conduction band, the photons, the incident light should have a energy greater than the band gap of the semiconductor material to make the electrons jump from the valence band to conduction band. Hence, when the light having the enough energy strikes on the device, more and more electrons are to be excited to conduction band, which results in the large number of charge carriers. This result of this process is more and more current flow starting, and when the circuit is closed, and hence it is said that the resistance of the device has been decreased. This is the common working principle of the LDR. Now let us see the characteristics of the LDR. LDRs are the light dependent devices whose resistance is decreased when the light falls on them, and that is increased in the dark. When a light dependent resistor is kept in the dark, its resistance is very high. The resistance is called dark resistance. It can easily high as a 10 to the power of 12 ohms, and if the device is allowed to observe light, as its resistance will be decreased drastically. If a constant voltage is applied to it, and instead of intensity of light is decreased, the current starts increasing. Photocells or LDOs are non-linear devices. Now talking about the H bridge. An H bridge is an electronic circuit which enables DC electric motors to be run forwards or backwards. These circuits are often used in the robotics. H bridges are available as integrated circuits or can be built from discrete components. Here the block diagram of the H bridge. We can increase the we can give the input to this circuit, and here are the four switches S1, S2, S3, S4, and this motor. Here S1 and S4 are here the two basic of the H bridge. The term is derived from the typical representation of the such circuit. H bridge is built for four switches. When the switches S1 and S4 are closed, a positive voltage will be applied across the motor. By opening the S1 and S4 switches, closing S2 and S3 switches, the voltage is reversed, allowing reverse operation of this motor. Operation. The H bridge arrangement is generally used to reverse the polarity of the motor, but can be used to break the motor where the motor comes to a sudden stop as the motor terminals are started, or to let the motor free run to a stop as the motor is effectively disconnected from the circuit. The following table summarizes the operation. If the S1 and S4 switch is closed, the motor moves right, and S2 and S3 closed, the motor moves left. By using this, the inductor stores here, storing the inductance so that all switches closed. Due to the storing of the inductance, the motor free runs. S2 and S4 are closed, the motor brakes, because this is the operation of H bridge. Now let us see the block diagram of this, and the power supply is given to the microcontroller, and the microcontroller is interfacing with the two LDRs, and the microcontroller gives the signal to the motor driver IC, and the motor driver IC to the motor, and this load. The microcontroller giving commands to the LDR1, LDR2 and the motor driver IC motor load. This is the block diagram. And the working when the intensity of the light becomes less when the sun changes its position. The panel rotates it with the help of the stepper motor. Based on the sunlight, the signals received from the microcontroller. The solar panel receives sunlight along with the LDR. The microcontroller receives the intensity of the light in the form of the analog signals from the LDR. Then the battery is charged by the solar panel, followed by the inverter supplied to the load. One of the most popular renewable energy sources has solar energy. Moreover, all the renewable energy sources available, solar energy has the smallest environmental impacts. Electricity produced from the photovoltaic cells does not result in air or water pollution, deplete natural resources as an endanger animal or human wealth. A solar tracker is a device for orienting a solar photovoltaic panel towards the sun. In solar tracking systems, the surface of the module tracks the sun automatically throughout the day. Tracking system increases the efficiency of the system considerably, thereby reducing the cost per unit of the system. In this, I will explain the working here. This is the block diagram of working panel, figure of the panel. In this, if the sun is in the east side, the solar panel moves towards the east side. If the sun is in the west side, the solar panel moves towards the west side. In this, the edges of this panel, we can implement the two LDRs, one LDR each side. One LDR in west side, one LDR in east side. If the sun rays is in the east side, the solar panel moves towards the east side. If the sun rays coming from the west side, the solar panel moves towards the west side. This is the working principle, working of the panel. This is the project kit. This is the solar panel and the light. This is the project kit, and this is the project kit. These are the applications, street light applications without using normal power supplies. It can be used in the vehicles for battery charging. It can also be used for remote areas, used in small and medium scale power generations, used in the domestic backup power systems. Now the advantages: trackers generate more electricity than their stationary counterparts due to the increased direct exposure to the sunrays. There are many different kinds of the solar trackers, such as single axis and dual axis trackers. Solar trackers generate more electricity and roughly the same amount of space needed for fixed tilt systems, making them ideal for optimizing land usage. Using as a tracking system helps maximize the energy gains during these peak time periods. Advancements in technology and reliability in electronics and mechanics have drastically reduced the long-term maintenance concerns for tracking systems. Now, future expansion. Remedy the motor binding problems due to the photosensor leads. This could be done with some sort of slip ring mechanism, smaller gauge wire, and a large motor with more torque, or a combination of the some or all of these ideas. Increasing the sensitivity and accuracy of tracking by using a different light sensor. A photo transistor with an amplification circuit would provide improved resolution and better tracking system. And use a UCN5804 Darling transistor array to reduce the number of discrete components used. Utilize a dual axis design versus a single axis to increase the tracking accuracy. Now, the conclusion: the paper has presented a means of controlling a solar tracking array with a embedded microcontroller system, specifically demonstrating a working software solution for maximizing the solar cell output by positioning a solar array at the point of maximum light intensity. This project presents a method of setting for tracking the sun and resetting itself for a new day. While the project has limitations, particularly in the hardware areas discussed in the section 4 and section 5, this provides an opportunity for expansion of the current project in future years. Thank you very much, friends. If you like the video, please like the video and comment, and please share the videos, and also please subscribe the channel. Thank you friends.